All right, in this video, I'm going to explain our velocities. So we want to have tangential velocity, and our first tangential velocity is going to come from our acceleration equals to the final velocity minus the initial velocity, all divided by time. This equation implies that the final velocity is just equal to the initial velocity, all right, plus the acceleration times time. Okay? So this is one of our tangential velocities. And of course, you know that we can write this as v is equal to v initial, where v is the final velocity, times a times t. So let's just call this equation number 8. Now there's another way that we could do the same thing, but even before we do that, how about I just go ahead and say, well, there's a relationship between tangential velocity and angular velocity. We've already visited this, and this is r theta for s. And then for v, we're going to have r omega. And then for a, we're going to have r alpha. So let's just refer to this as equation 9. So let's go ahead and substitute those in. So for the initial velocity here, we can write r omega equals to r omega initial plus r alpha times t, and we can just divide both sides by r, and we end up with omega is equal to omega initial plus alpha t. Okay, so we would consider this one to be equation number 10, and look at how we derived it directly from the tangential. Okay, so we have this first equation. The next equation is going to be based on the following. This equation number 9 here is going to be VF. So it's going to be the final velocity equals to S final minus S initial over T. Is that right? Yep, over T minus the final velocity. Minus the initial velocity. How in the world? All right, so this is going to be 11. Equation number 11. So if we just go by the same rules of substitution as we did before, we would have something very similar. So we're going to say r omega equals to r theta final minus r theta initial all over time minus r omega initial. So again, the r's are going to be applied in the denominator across the equation, and we end up with omega is equal to the angular displacement divided by t minus omega initial. This is equation number 12. All right, so that should be plenty enough for you guys to go on. Make sure you do the homework after this.